Good morning, kids. So, in this video, I am going to try to explain to you the concept of factors and multiples. It's a really simple but important concept that you will need from now on in your academic life. Well, I had the definition prepared here, so let's check first factors. Okay, take into account that factors is the same than divisors. Okay, so you can hear this word or this other word and it means exactly the same. So factors or divisors of a number are those numbers that you can use to divide it and you won't get a reminder. So let's take for example the number 12. Let me explain what I mean here. And we're going to try to find the factors of 12. Okay, so remember all of those numbers that you can use to divide it. So let's start in order. With the number 1, can you divide the number 12? 12 divided by 1 is 12. So yes, because if you make this division, you don't get a reminder. So the number 1 is a factor of 12. Look, I am going to highlight it in or circle it in another color. But also the number 12. So the 12 itself, it's one of its factors. And you may say, why, teacher? Because we divided it by 1. But let's look at the opposite. 12 divided by 12. And you get 1. Once again, you didn't get reminder. So 1 and 12 are factors of 12. So 1 is the smallest factor of 12 and 12 is the biggest factor of 12. That's why I put the 1 here in this end and the 12 in this end. The other factors are going to be in between. Let's take for example the number 2. If you divide 12 by 2, once again you don't get a reminder and you get 6. So 2 and 6 are factors of 12. Let me write them here. 2, 6, okay. Why the 6? Because once again, 12 divided by 6 is 2 and you don't get a reminder, okay? Let's continue. 12 divided by 3. Can we divide the 12 by 3? Yes, we get 4 and we don't get a reminder. Again, it's an exact division. So, if we switch it and we write 12 divided by 4 is 3, so that means that the 3 and the 4 are factors of 12. So let me write it in the list. 3 and 4. Okay? And what happens? When do you know when to stop? Okay? So, let's say that we continue. 12 divided by 4. But wait, look. We are trying with a number that we already knew was a factor. So that means that we end. Okay? We finish when we start trying with a repeated number. Okay? So all of the factors of 12 are 1, 2, 3, 4, 6, and 12. There are no more. No more, no less. All of the factors of 12 are contained in this list. Okay, let's see. Let's try with another number. Okay? For example, factors of the number 8. Okay, so let's do it. So let's start with 1. 8 divided by 1. Did you get 8? So you know that 1 is a factor and 8 is a factor, okay? So don't forget to separate with commas. 1 and 8 are factors. And if you do the opposite, it's going to be the same. Let me write it. It's not necessary, but 8 divided by 8 is 1. Okay, so you know that these two are factors of 8. Let's try with 2. 8 divided by 2 is 4. Excellent. Excellent. And you know that 8 divided by 4 is 2. That means that 2 and 4 are factors of 8. Let's write them in the list. 2 and 4. Okay. Let's see if we find something in between these two. Okay. 8 divided by 3. Is it possible? No, because if you make the division, look, I am going to do it over here. 8 divided by 3. 3 fits in 8 twice. 2 times 3 is 6. We subtract, we get 2, and there's nothing else to drop down, so that means that here we have these two as a reminder. So that means that 3 is not a factor or a divisor of 8. So this one doesn't work. And let's try with 4. Okay? 8 divided by 4, but look, we already found that the 4 was a factor of 8. So that means that we don't need to do it anymore. We found everything. And here, in this list, there's only a comma in between these. The factors of 8 are 1, 2, 4, and 8. Let's see another example, really quickly. The factors of the number 25. Okay? Factors of 25. Okay, let me create this. So let's start with the 1. 25 divided by 1 is 25. So you know, sorry for those awful brackets, that the 1 and the 25 are factors of 25. Okay, let's see what happens with the 2. 25 divided by 2. It doesn't work, because 25 is an odd number and it can't be divided by 2. 25 divided by 3. Is it possible? No, the 25 can't be divided by 3 without getting a reminder. What about the 4? 25 divided by 4. Does it work? Nope. Let's try with the 5. 25 divided by 5. In this case, yes, it works. 25 divided by 5 is 5. So that means that 5 and 5 again? Yes. Sometimes we can get the same number that we tried as a result. So we are not going to put it twice. We are going to only put it once. And we finished because we already found the same. We found a repeated number, so that's all. We don't need to continue anymore. All of the factors on 25 are only these 3. 1, 5, and 25. Okay? So that's it. That's how you find factors. Okay? Now, let's remember what we discussed in class. What is a prime number? Okay? Okay, so prime numbers are numbers that have exactly 2 factors or divisors. No more, no less. Okay? So, let's make a list. 1, 2, 3, 4, 5, 6, 7. Sorry, I wrote 6 again. 7, 8, 9, 10, 11, 12, oh, sorry, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I'm not going to do it only until 30. 27, 28, 29, 30. We're not going to do anymore, but it's infinite, you know. Let's see which numbers of these are prime numbers. Remember, prime numbers, they have, or a prime number has exactly, and this exactly is really important, exactly two factors. So how many factors does the number 1 have? Well, the number 1 has itself as a factor and nothing else. So 1 is not a prime number because it has only one factor. Prime numbers have exactly two factors. The number 2, what factors does it have? It has 1 and 2 and no more. So it has exactly two factors. So 2 is a prime number. The same as 3. 3 has 1 and 3 as a factor, but not anymore. But the 4 is not a prime number. The 4 has 1, 2, and 4 as a factor. So it has 3 factors, doesn't have exactly 2 factors, so it's not prime. 5 is prime because it only has 1 and 5 as factors. 6 is not prime because it has 1, 2, 3, and 6 as factors. 7 is prime, 8 not, 9 not. Because you may think, oh, teacher, the odd numbers are the prime numbers. But no, look, 9 is not a prime number because it has 9, 3, and 9 as factors. So no, not exactly 2. 10 is not a prime number, 11 is, 12 not, 13 yes, 14 not, 15 not, 16 not, 17 yes, 18 not, 19 yes, 20 of course not, 21. Think about it for a second. Is it a prime number or not? What are the factors of 21? 1, 3, 7, and 21. So, does it have, sorry for this, does it have exactly two factors? No. Be careful. Okay, so as a challenge for you, I'll let you find which of these remaining numbers in this list is prime and which is not. Okay? Question: what do you think? Can any other number that is even apart from 2 be a prime number? Think about it. Okay? The answer is no. So all of the other even numbers are not prime numbers. But now, think about the other 23, 25, 27, 29. What of those are prime and one not? Okay? Think about it for yourself. That's a challenge for you. By the way, the numbers that are not prime are called composite. Okay, don't forget this number, this name. Okay, but that's it for the concept of factors and also for prime numbers. Look at this beautiful increasing F letter. So let's go back to this definition that I had prepared. Okay, multiples. The multiples of a number are those numbers that result from a multiplication with it. So, excuse me, let me get rid of that 8. So, what do you mean, teacher? Well, it's easy. Remember, the multiples of a number are those numbers that result from a multiplication with it. So let's think for example, of multiples of the number 6. Okay, so let's do multiplications with the number 6. So 6 times 1 is 6. So 6 is a multiple of itself. 6 times 2 is 12. So 12 is another multiple. 6 times 3, 18. 6 times 4, 24. Sorry, the comma. 24. What will be next? 6 times 5, 30. Next, 36. Next, think about it, 42. Next, 48. And you can continue. Think about it, kids. Will you ever reach an end for the multiples? No. Okay? No. Because, let me continue. Let me continue. Because now I want to address another mistake that I always see when I teach this concept. The next one. The next one is 54. The next one is 60. And some of you stop here because you think that the multiples are the number in the table of the numbers. For example, multiples of 6 are the numbers in the table of 6. And you usually know the table of 6 until 10. But guess what? It's infinite. We only do it until 10 because that's convenient. But the multiples are infinite because after 60 you can get 66, you can get 72 and go over. Okay, so the multiples are infinite. Okay, let's do another one and let's think of some exercises for you. Okay, so multiples. Sorry, I wrote with red all of that. Of 9. Now, actually, let's do a smaller number. Multiples of 2. Those of you that are quick will understand that the multiples of 2 are all of the even numbers because those are the table of 2. Like 2 times 1 is 2. 2 times 2, 4. 2 times 3, 6. 2 times 4, 8. 2 times 5, 10. And we continue. 12, 14, 16, 18, 20. And you don't stop here. 22, 24. Yeah, and we understand that they are infinite. Okay? I just want you to understand that. Multiples are infinite. Question. Are factors or divisors infinite? No, they are not. Factors or divisors are not infinite. Look, the factors of 12 are all this, not more. The factors of 8, 1, 2, 4, not more. They are not infinite, but multiples are. Okay, be careful with that. Never forget it. Okay, last one. Multiples of 3. Okay? 3, 6, 9, 12, 15. What's next? 18. What's next? 21. And it continues. You don't stop at 30. Okay? Right? You don't stop at 30. Because they are infinite. There are more multiples after 30. Okay? But of course, we are not going to write infinite numbers. It's physically impossible. But anyway, we can understand that they will never end. Okay? Now, last thing. So, some exercises for you. You will have to deliver these before 2:05. Okay? Before our class of today should have normally ended. So, it's really, really, really simple. Okay? So, first, write the factors, and I will write these, all of the factors, because when factors or divisors, I am going to put also this name here. Sorry, I forgot how to write. Divisors. Factors and divisors are the same, and they are not infinite. Okay, so of. So first, factors of 16. B. Factors of 20. C. Factors of 100. Don't worry, they are not that much. They are not that many. Okay? A, B, C, D, E, F. Okay? Factors of 36. Factors of 72. And factors of 90. Let's leave it like that. That's for the factors. Now, write, the second point will be write the first 20 multiples, sorry, of, so these are going to be less, A, B, and C. The first 20 multiples of 7, the first 20 multiples of 20, don't worry, it's not that much, and the first 20 multiples of 50. And finally, make the list of the first or the next prime numbers after, until which number did we get? We got until the 20, the 19, okay? So after 19. So you know that the prime numbers start from 2, 3, 5, 7, 11, 13, 17, 19, but I want you to write the list of the next prime numbers after this. How many? Make the list of the next, okay, 10 prime numbers after 19. So 10 prime numbers after 19. What are the next 10? That's your work for today, kids. Okay, so good luck. I will receive it in my mail and I will check it as a classwork, kids. So please use your time wisely. If you have any question, I will be checking my mail.